Hey everyone, today we're going to discuss about simple annuity 2. So this is similar with a simple ordinary annuity in our previous video. However, in an annuity 2, the periodic payment is made at the beginning of each payment period. So we have the keyword here, beginning of each payment interval. So when we deal with ordinary annuity, the payment is done at the end of the interval, while in the simple annuity 2, the payment is done at the beginning of each payment interval. So there will be a small change in our formula here, but the way it works is still the same. So we still have our I and N. I is the interest rate and N is the total number of conversions per period. So still there. So we're going to have our future value of the simple annuity due. Remember that their change is that the payment is done only at the beginning and not at the end. So the future value is FV, future value, is equal to P, the periodic payment, times the fraction 1 plus I, the interest rate, raised to N is the total number of conversions, minus 1 divided by I, then times 1 plus I. As we can see here, this part here is the formula for the ordinary annuity. But there's an added part here for the annuity due, which is 1 plus I. This is to account that the money is paid at the beginning of the month, or the interval rather than at the end. So that's for the future value. For the present value, it works the same way. We just have to add the I plus 1. So the present value is PV is equal to the periodic payment times 1 minus 1 plus I raised to N. I is the interest rate, while N is the total number of conversions, divided by I, interest rate, times 1 plus I. As we can see here, it's still the same as the simple ordinary annuity, but it's only multiplied with 1 plus I to account for the annuity due. Okay, let's have an example here. 10,000 pesos is deposited at the beginning of every 6 months on an account that has an interest of 4.5% compounded semi-annually. How much will the money be after 5 years? So we're talking about a money that will grow on an account and will be deposited in the future. So this is a future value. So let's have FV. That's the future value. Take note that we're going to still have our I and N here. So I is equal to annual rate over the total number of compoundments per period. So the annual rate is 4.5%. So R is 4.5%, which is equal to 0.045. And the K is the rate of compoundment. Since it is semi-annual, K is equal to 2. So our I would be 0.045 divided by 2. And as such, this is equal to 0.0225. So that will be our interest rate. Let's have the value of N this time. So N is equal to T times K. So time times the number of conversions. So it will be after 5 years. So 5, and the number of compoundments is semi-annual, so 2. So N is equal to 10. So let's start solving for the future value of the annuity 2. So this is FV is equal to the periodic payments times 1 plus I raised to N minus 1 all over I times 1 plus I. So that's our formula right there. the periodic payments is 10,000. Times 1 plus I is 0.0225 raised to n, which is 10, minus 1 all over 0.0225 times 1 plus I is 0.0225. Another word of advice, let us be careful on how we compute it using the calculator. Let's start first with this term here in the middle. Let's start by computing the fraction on your calculator, then compute for this period, multiply to the periodic payment, then afterward you multiply it here. Since you can have 1 plus 0.0225 mentally, you just multiply it right away with 1.0225. So if we use our calculator, we will begin with 1 plus 0.0225, then raise it to 10, subtract it by 1, then divide by 0.0225. Then multiply it with 10,000 and multiply it with 1.0225. The final answer would be 113,249.11. So 113,249 pesos and 11 cents. So that's how much the money will be after 5 years. So that's it for the annuity due, and just remember that it is just similar with the simple ordinary annuity. In our next video, we're going to have the regular payments of simple annuity. So I hope you guys learned a lot today. So thank you guys for watching, and see you guys on the next video.